next challenge is to draw a triangle and label it correctly with the information that's given. So we're talking about a fire ladder, and the maximum angle of elevation is 72 degrees. That would be 72 degrees with the ground that the ladder makes. The ladder is 110 feet long. What is the maximum safe rescue height? So let's draw a picture. There's the ground. We've got a building. It's on fire. Will the ladder reach? The maximum angle of elevation is 72 degrees. That angle has to be made with the ground, with the horizontal. So it's not the other angle in the triangle. It has to be this one. There's my right angle. I've been told the ladder is 110 feet long. And I want to know how high up that ladder will reach. So technically we have this triangle. And we're trying to find out how high up the ladder will reach. If I look at the given information, the angle I have corresponds with the opposite side that I need and the hypotenuse. So make sure you are in degree mode. Nice thing about applications is we'll always stick with degree mode and multiply both sides of the equation by 110. We did that in order to isolate x. Put that into your calculator, and we should find out that the ladder can reach 104.6 feet. Hopefully the fire is not higher than that. For this example, we have a tower that is casting a shadow. The shadow would be on the ground, and we're asked to find the angle of elevation to the sun. So let's draw a picture. The ground. A tower that's supposed to be some sort of medieval tower. I don't know, you can say. And the sun is causing a shadow to be cast onto the ground. Read this carefully, because the numbers are kind of backwards. So read carefully. The length of the shadow of a 200-foot tower, it's the tower that's 200 feet. And the shadow that's 70 feet. So now that I look at it, my picture is obviously not drawn to scale. That's okay. We can still work with it. We want to find the angle of elevation. And again, that angle is always the angle attached to the horizontal, not the other angle. And again, if you need a simpler triangle without the silly pictures, certainly you can do that. To solve for the missing angle, we'll set up a tangent equation. And because we're looking for an angle, we'll have to use inverse tangent. Calculator in degree mode. We should find an angle of 70.7 degrees. When you read this, question, you realize that there's a lot more information involved. And actually, two triangles are being described. So we will have two right triangles, one on top of the other one. We've got, it's a little bit harder to draw. Once you hear one like this again, you'll understand it. We've got a building. From a point 200 feet in front of the building, the angle of elevation to the bottom of a smokestack, first we're reading about this, so there's a smokestack on top of the building. And the angle of elevation to the bottom of that smokestack is 35 degrees. The angle of elevation from the same point to the top of the smokestack would obviously be bigger, and it's 53 degrees. Bear with me for 1 second while I lock that in place. So what we really have, that might be a little bit hard to look at. So what we really have is a small triangle with this information, and we have a large triangle. With that information, if we find the height of the building here, and then we find the entire height of the building plus the smokestack, using the triangles, then we'll take those values and subtract them to find just the height of the smokestack. So let's find each height individually using a tangent function. Multiply both sides by 200. Use your calculator to find that the height of the building is 140 feet. Then we'll find the total height using tangent as well. Multiply both sides by 200. And use your calculator in degree mode to get a height of 265 feet. And we just want the height of the smokestack. So we'll take the entire height and subtract the building height. And that's the height of the smokestack.